Welcome again to Math Essential Vector Calculus. We are still with the curl and we are discussing it to this time in spherical coordinate system. As we have discussed before, the curl is simply the multiplication, cross multiplication of nabla and f, where nabla in spherical coordinates equal to direction r multiplied by partial r plus direction theta multiplied 1 over the scaling factor r partial by partial theta plus phi multiplied by 1 over the scaling factor here is 1 over r sine theta multiplied partial by partial phi. And we have here the vector f has some component in r direction, have some components in theta direction, and have some component f direction. And once we apply nabla to it, first we will do the differentiation, and after that we will do the cross product. What we have get used to, we just divide this big equation here to three terms, 1, 2, 3, and operate cross product and the differentiation for each component. Then we combine everything to get expression. So we'll do one by one. We have here first r cross partial f vector by partial r. Then we just do the representation. We have r cross, as we said, we'll do at the end. Then we just make the differentiation for each component. Each component here also will do, since we have two things multiplied by each other, so we need to do the multiplication rule. So again we'll divide this summation here to three component, 1, 2, 3, and do the multiplication rule. And also, if we recall that we need to use this table, because not always the unit vector has a derivative of 0. For example, if we have a length, always we have a derivative of 0. We differentiate in terms of angles, either phi or theta. Most probably will have non-zero component of this derivative. So for our derivative, we have always 0. So most probably here we'll get this thing is equal to 0, and we'll be left with this component. And all what I am doing here is that I'm getting what is resulting here, make again the summation and put in this equation. Then now I'll apply the cross product. As a fast memory, if we have r cross r, this will be 0. Same, phi cross phi will be 0. Theta cross theta will be 0, because the angle between them is 0. Like between two vectors, for example, let's write, as we have learned, r theta and phi. If we go from r to theta, I mean we are cross product r with theta, we will left with phi. If we go from theta cross phi, we'll be left with r. And if we go from phi to r, we will be left with theta. If we go in the opposite direction, means if we make cross product r phi, then we will get minus theta. If we do cross product phi theta, we will get, in this direction, we will get minus r. And if finally, if we go from theta to r, we will get minus phi. So finally, here we have r, then this component will tend to be 0. R theta, then we are moving in normal way, that's why we get positive phi. R phi, then we get minus theta. Now we do the same thing with theta component. We have three subderivatives, and in this each of them we have them apply the multiplication rule. We'll get the terms here, and after we do the multiplication rule, we just go to look to our table and confirm whether the resulting function will bring a unit vector or will bring 0. So here we actually didn't get a 0. This component as well as this component has a value here, theta and minus r. That's why this term appears. And then we just take this component, move here, and this component and move here. Finally, for the phi component, fortunately this partial phi by partial theta is equal to 0, so this will equal to 0, and we will be left with this one. Then we sum everything together here and apply the cross product theta r. We are moving in the opposite direction, so we'll get minus phi. We do theta theta, then this component and this component will tend to 0. We have then theta r, this moving again in the opposite direction, but we already have a minus sign. Then we'll to in overall we have a positive sign, and finally theta and phi, this moving in the appropriate way, then we'll get positive r. Now we move to the last part, which is the direction of phi, and we do the same. We split into three components. Here we apply the multiplication rule, and we check whether the unit vector derivative has a value or not. And actually for phi direction, all the unit vector, as you can see, has a value for the derivative. It is non-zero. That's why you will have a lot of components, these additional components here, these three additional components. And then again we sum everything together. For what I have done, I have rearranged it actually to separate r, theta, and phi components. And as we know, this is phi and this is phi, so this component will disappear, will tend to zero. And then we just apply the cross product here, phi cross r, which will bring positive theta here, and we have phi cross theta, which will bring minus r, and the remaining parts we will set here. And of course, don't forget that we have 1 over r sine theta. Now we sum everything together. I have rearranged it to we have r, theta, and phi component. Some terms here can be rearranged in an easier way. This, especially this term and this term, or this term. So we just do some manipulation. I have two recalls here, this one and this one. If we recall 1 over u partial u a by partial u, where a is some function of u, if you do this derivative, you will left with 1 over u multiplied by u partial a by partial u plus a. And if you make the multiplication, this one distributed inside, you will be left with partial a by partial u plus 1 over u multiplied by a. And actually what you can see here is exactly this component as well as this components, but in different notation. This means we can rearrange this one like this, and we can rearrange this one like what you can see here. The second recall is about sine alpha. So if we have this arrangement, means partial by partial alpha of the function sine alpha multiplied by some function b, which is a function also of alpha, then this will result in sine alpha. We don't differentiate, then differentiate the second function partial p by partial alpha, then p, and differentiate sine alpha by partial alpha, which will bring you cosine alpha. And if you compare what is here with this function here, then you can rearrange what you can see here like this. Now we have proved the curl in spherical coordinates, but this is hard to remember. This equation is a little bit difficult to be memorized. So we have an easier form, which is a matrix form. Block cross f will be equal to 1 over r squared sine theta. Then we organize our vectors r, theta, phi, multiplied by the scaling factor, which is 1 here, r, and r sine theta. Then we put our derivative, partial by partial r, partial by partial theta, partial by partial phi. And then we put our function fr, f theta, f phi. Then again we multiply the last row by the scaling factor, which is 1 r and r sine theta. Finally, with a wrap up of this video, we have learned how to calculate the curl in spherical coordinates. And next time we will summarize the curl and check for some applications.